day, in this video, we will learn how to solve a problem based on the 4th edition of Fluid Mechanics and Hydraulics by Julisania, particularly in Chapter 2, Principles of Hydrostatics, Variation in Pressure Below Layers of Different Liquids. So we have here problem 2-11. In the figure shown, so this is our figure, if the atmospheric pressure is 101.03 kilopascal and the absolute pressure at the bottom of the tank is 310 kilopascal, what is the specific gravity of olive oil? So we have listed here our given. The atmospheric pressure is 101.03 kilopascal and the absolute pressure is 310 kilopascal. Let us also take note the specific gravity for each of the liquid inside the tank and their corresponding height. Now to start our solution, since we have already have the given and the figure, let us recall that gauge pressure is equals to the absolute pressure minus the atmospheric pressure. Now we will substitute the values we have since it is all given. 310 minus 101.03 is equals to 208.97 kilopascal. So this is our gauge pressure. And this gauge pressure we have here is equals to the summation of all the pressure produced by this liquid in the tank. And it is expressed with this. Pressure is equals to the summation of the product of specific weight and the height it occupies in the tank. So this is our equation for this problem since we have mercury, olive oil, water, and the standard automotive engineer's oil. So plugging in our values, we have 208.97 is equals to the product of the specific weight of mercury and the height it occupies, and it goes the same for all of the liquids. But before that, let us recall that in order to get the specific weight of a certain liquid, if you have only been given the specific gravity of it, you have to multiply it with the specific weight or the unit weight of water. And here, we are in kilonewton per cubic meter, so that our values, the units of our values will later on correspond to each other. So 9.81 kilonewton per cubic meter times 13.6, the specific gravity of mercury, multiplied to the height it occupies, plus the specific weight of our water multiplied to our unknown, the specific gravity of olive oil, and then multiplied to the height it occupies, plus again the specific weight of water multiplied to the height it occupies, plus the specific weight of our SAE oil multiplied to the height it occupies. So we have here our equation now, and we have the values that will find the specific gravity of olive oil. And if we're going to solve for that, we will get that our specific gravity is 3.45. But how it became unitless, and we will show you that. Since 1 kilopascal is also equivalent to 1 kilonewton per square meter, it's just the same with that. You can cancel that out. And if you're going to multiply the specific gravity of a certain liquid to its height, you can get also that it is also the same with kilonewton per square meter. And it goes the same for this and this. Now all of our values here are the same. So if you're going to solve for our specific gravity, you will get a unitless answer. So our specific gravity is 3.45.